So continuing in section 2.1, we just finished up looking at solving this problem. So we had added 21 to both sides, and then we got 11x is equal to 11, and then divide both sides by 11 to get x equals 1. And I said that you should always check your answer. So this one would be more difficult to check by hand because it's going to end up being fractions, right? We're going to get a fraction on this side, and then we'll have two fractions here without like denominators. So like I said, instead of doing it by hand, use the calculator to do it just to check your answer. So looking at the calculator, we will take, and in place of x here, I'm going to put 1 in. So I'm going to say, and I'm going to surround my numerators that have the expressions with parentheses. So on the left side, and I always want to go back, remember, go back to this original. Don't use one of these. Don't use this one. It would be easier to use this one, but what if there was an error made along the way? You always want to go back to the original. So on the left side, I get negative 0.5. Now on the right side, let's see what we get. If we get negative 0.5, then we know that our answer is correct. So wherever I have an x, I'm putting in 1. So I've got I got x plus 5 over 7. And remember, anything with the expression, put the parentheses around. And see, the left side is equal to negative 0.5, and the right side is equal to negative 0.5. So I did it correct. Now, I had pulled up a whiteboard here because I want to show you another method to find the least common denominator without writing out all these multiples, because that can get very tedious. And if you can start getting into larger numbers too, and it gets harder to do. So instead, let's do this. So the numbers that our denominators were, we're going to make a little table. And sometimes we'll have to make the table bigger, but I'll talk about that why in a second. And we're going to take those denominators and we'll put them on the left-hand side here in the first box, in the first column. And then to the right here, we're going to prime factor these. So what's it mean to be a prime number? A prime number is divisible by itself and 1. 4 is not prime because it is divisible by 2. 2 is prime. So we make these little factor trees, and then we say, okay, 4 is made up of 2 times 2. How about 14? Is 14 prime? It is not. 14 is divisible by 2 also. It's 2 times 7. So I've got a factor of 2, and I have a factor of 7. So I'll put my factors in the columns. And when I have a different type of factor, I'll make a new column. And then the last one, 7, well, that's a prime number, but it has no factors of 2, but it has a factor of 7. So anything that is blank, I'm just going to put a little line through. And then to come up with the least common multiple or the least common denominator, you're going to take each column and you're going to look at the most factors. So looking at the column of 2's, the one with the most factors is this. So I'm going to write down that. And the one with the most factors in column 2, well, both of them have 1 7. So I'm going to write that. So 2 times 2 times 7 would be equal to 28. And that ends up being the number that I chose. And we'll look at this again when we do some more problems. But this is how you can find the least common multiple instead of writing out all of those multiples. Let's take a look at another problem. All right, so let's take a look at another one. So the problem is 2x over 3 minus x is equal to x over 15 minus 4 over 5. So here again we have numbers in the denominator. We want to get rid of those by multiplying by the least common denominator. So we could list out the multiples. The multiples of 3 are 3, 6, 9, 12, 15, 18, 21. The multiples of 15 are 15, 30, 45, 60. And the multiples of 5 are 5, 10, 15, 20. And so the least common one, you have to find something that they all have in common, is 15. Now, to do it using a table, what I would do is I would first write out the 3 denominators. Then I would take and write out their prime factors in columns. So 3 is prime. So that creates a column of 3's. 15 is not prime. It's made up of 3 times 5. So that creates a column of 5's. And then 5 is prime. So we've got no 3's, but we do have a 5. The least common denominator, or least common multiple of the denominator, would be take the highest from each column. So 3, there's 1 3 here, 1 5 here. The highest of each column would be 3 times 5, or 15. So either way, we get 15. So I'm multiplying both sides by 15. So 15 here and 15 here. But I have to remember that means I'm multiplying everything by 15, each term. So and I'm writing this out to show you where the 15 is going. And I think it's a good idea to kind of keep it organized by doing this. So now I'll look at this and I'll say, 3 goes into 15 5 times. Remember, the goal is that all the denominators get canceled out. 15 cancels out 15. It will be 1 over 1. And 5 goes into 15 3 times. So now let's rewrite this with our new numbers that are out front. We have 5 times 2x. And again, I think it's a good idea to write this line out, because then you can see this would cancel out to 1. Then you can see what needs to be multiplied still. If you do the multiplication, if you do the division, the factoring, division, and the multiplication in one step, sometimes you can make just a minor error and it'll throw your answer out. Here I get 10x minus 15x is equal to x minus 12. This, much nicer problem to work with than this original. So combine, collect the like terms. Do I have any like terms? I sure do. I have 10x minus 15x on the same side of the equal sign. So that means I just take the 10 minus 15 to get negative 5. Rewrite the variable with the exponent. Now collect all the variable terms onto one side, collect all the numbers onto one side. And I end up with, I have an x here. I want to move it over, so I'm going to subtract x from both sides. I get negative 6x, because remember there is a 1 here. So negative 5 minus 1 is a negative 6, is equal to negative 12. Then I'm going to divide both sides by negative 6, because I want to isolate this x, and the negative 6's will cancel out. And when I divide like signs, I end up with a positive result. So 12 over 6 is 2, and 2 like signs, whether they're 2 negative or 2 positive, will result in a positive end result of multiplication or division. And 2 unlike signs would result in a negative sign. So this is my answer here. And again, you want to check it. And you want to check it by taking that proposed solution, and you're going to go back to the original. And in the original, I'm going to place wherever I had, oops, that's not the original. Wherever I have an X, I put a blank spot. And in its place, I'm going to put the number 2. So plugging in 2 here, here, and here. So, and again, why work with all these fractions? Let the calculator do the work of just the checking. 2 times 2 divided by 3 minus 2. That's negative 0.66. And then check the right side. The left side is negative 0.66. The right side, I should get the same value. I do. So then I know I've done it correctly. So that is how you do these type of problems. Try more of them in the MyLab Math and see how that goes. And if you run into problems, please let me know and we can go over more of these types. So in the next video, we're going to be talking about when you have not just a number in the denominator, but what about when you have an X in the denominator? So that's what we're going to be doing next. So a little bit different than the ones we did. So this was considered a linear equation. These have constants in the denominators, just numbers. A rational equation is what we're looking at next, because those include at least one variable in the denominator. So if you have X in the denominator, it's considered a rational equation, and we'll treat it very similarly to what we just did, but we're going to look at solving those next.